Hello, this is Matthew, and welcome to today's video on installing OpenVMS on x86. At long last, we have been waiting for years, many of us, to have access to the x86 port of OpenVMS as hobbyists. It has been in field test for a while. It has been made available for evaluation for actual paying VMS customers and for software developers, ISVs, for their work to port their software over to OpenVMS on x86. But the folks at VSI, VMS Software Inc., who now are responsible for development and support of OpenVMS and who performed the x86 port, they have always been saying that they would have a community license, a hobbyist license for VMS on x86, but they were waiting for it to get to the point where it was stable and had some native compilers so you could actually do something with it and not have to have an Itanium system to install the cross compilers on, which is how you had to build all of the software throughout the development and field test process of the x86 port. But now, at long last, they are starting to reach out to folks who have previously signed up for the Alpha or Itanium hobbyist licenses, what they call the community license. And they are, my understanding is they're just doing it in batches. It sounds like somebody in the forums said weekly on Fridays, they're releasing the next batch of users into the x86 hobbyist program. So if you have previously requested a license, you just need to wait to be contacted by VSI by email, letting you how to get in. And the way you get the software is through the VMS software service platform. And so this is their basically support portal that you use if you have a support contract for things like support tickets, as well as download the software that you're entitled to. And I think this is a pretty neat way for VSI to do this because they essentially just add your account to an organization that I'm guessing this is the VMS x86 community organization. And then that way they're able to give you access to the software just like they do to their paying customers. So as you'll see in here, they are actually releasing the updates and some open source packages and some of the layered products in addition to the operating environment, the operating system itself. So hopefully what that means is that as updates, any security fixes, bug fixes, as they release those ECO kits, it looks like hobbyists should be able to download those and apply those to their systems to keep them up to date, which is very cool. If you have not gotten the email yet, it's worth going to this sp.vmssoftware.com site and just trying to reset your password with whatever email address you had signed up for your community license with. I was actually able to do that and get in, and they've set up my account before I even got the email from them. So you may still need to wait to be in a batch that they have created the accounts for and added you to the community organization. But if you're really impatient and you want to try and get in a little bit earlier, again, if you have previously joined their community program, you can try resetting your password on this sp.vmssoftware.com site and see if it recognizes your email address. So with that said, let's dive in. If you go to this packages page, it helps to filter by only accessible. Otherwise, you're seeing a bunch of downloads that you are not able to access as a hobbyist. I believe these were just older field test versions of some of the operating systems, some of the packages. I don't think they're really holding too much back from the hobbyists. If you do only accessible here, you can see that you get the C compiler, the C++ compiler, both DEC forms and FMS is down here somewhere. Yeah, VSI FMS. So both of the forms development packages that are out there in the VMS world. DECnet Plus, this is actually included in the operating system. I'm not sure why it's also a separate download. DECset is their development tools toolkit. So the module management system, which is their sort of make equivalent, their software build tool, and the I think the static code analyzer is still part of this. The source control system is part of this. DexSite used to include LSE, the language sensitive editor, but from what I can tell, LSE has not been ported to x86, so it's just some of the other software development tools that are part of DexSite now. The Fortran compiler is available, and I think that's it for compilers. I don't think the basic compiler is available yet. That's actually, I think, pretty important for a lot of VMS customers, but watching the VMS news group, comp.os.vms, it sounds like there's a complication with basic, the way that it was implemented before. It wasn't as straightforward to port as some of the other compilers. So my understanding is that's coming, but not available yet. I don't see the Pascal compiler here. I don't know if they're ever going to port that. I don't see the COBOL compiler here. I don't know if they're ever going to port that. Those were a couple of compilers that were available, like back to VAX, hobbyists. So in any case, a good collection of software here, and as well as open source packages that they've ported over and packaged up as VMS packages. So things like, looks like a LUAP interpreter, LDAP. This may be the Open LDAP server, and things like Redis. And I saw RabbitMQ up here. Yeah, LibRabbitMQ, HA proxy. Honestly, I don't know why you would be running any of these on VMS. Just run them on Linux or BSD. But hey, VMS is on x86 now, so may as well start porting some software over to it. But what we're interested in today is the operating environment. So this is the actual CD image to install the operating system, x86 E921 operating environment. So you can just go in here and download this zip file, which will have a CD ISO image inside of it. And if you go back to packages, you also want to grab the x86 community pack. So packs are the license packs, the license keys for VMS software. So they just have the same license keys for everybody. These aren't uniquely generated for you or anything like that. And these license keys are good for a year through April 1st, 2024. This is similar to how they were doing the community licenses for Alpha and Integrity. Once you sign up, they just give you the same file with the license keys they send to everyone. And then once a year, they just generate a new one with a new expiration date, another year out, and send that out to everyone. That's a little different than back in the original hobbyist program that was somewhat, or you had to have a Decus affiliated account, and they actually generated unique keys for you. And so when you got your license, it was good for a year from the date that you got it. But I guess just for simplicity, they've shifted to just having one set of licenses for everyone, and then they just reissue them yearly. So with that all downloaded, let's try and get this up and running. Now, the VMS for x86 targets virtualization platforms. So you are meant to run it under VMware. They also support KVM, the Linux kernel hypervisor, and VirtualBox. Today we'll try in VMware, and then I might quickly at the end just show how to get up and running in KVM, because I think that may end up being the preferred way for a lot of people. And there are some very specific requirements about how you set up your VMs. So it's a very limited hardware profile that's supported, which makes sense in the, it makes a lot of sense to target virtualization in VMware, because then they just have sort of one kind of system that they need to support. And of course, not worry about all sorts of drivers for all the different network cards and disk controllers and everything that's in all the different chipsets that you might want to run on hardware. I believe they are also going to support some particular HP servers for the people who really want to run it on bare metal. But for now, just stick with VMware or KVM, or apparently VirtualBox. I don't use VirtualBox, but they have some instructions for that as well. So I have my VMware ESXi server here. We can log in. And I've already uploaded the ISO to a data store that's accessible to my server. So if you scroll down here, you can see that x86 E921OE ISO. So you need to make sure that you've put that up on your VM server. And we'll go ahead and create a VM for our VMS box. So create a new virtual machine. And I'm just going to call this VMS 86. You want to say the guest OS family is other, and it's an other 64-bit operating system. VMware, of course, at this point has no idea what VMS for x86 is. I will create a disk for it. I'll just give it 2 CPUs. Memory, I believe they say the minimum is 8 gigabytes. I'll give it 16 gigabytes. And I will give it a 72 gigabyte hard drive. We'll be able to load all sorts of stuff up on it that way. They do mention in the documentation they recommend a second, maybe 8 gig hard drive for dumps to go not on the system volume. I'm not going to worry about that now. That would require extra setup in any case. But if you are, running something for real, probably stick to the recommendations from the documentation. Now, by default, VMware gives you a SCSI controller, and it attaches the hard drives to the SCSI controller, particularly when you choose this particular profile, the other 64-bit machine. The CD drive on VMware, you can only attach to a SATA controller or an IDE controller. You can't attach the CD drive to the SCSI controller. And the reason that that's important is because in my brief experience here so far, the VMS bootloader and operating system can really only see disks or devices on the storage controller that it's started up from. So if I have my hard drives on the SCSI controller and I have the CD drive on the SATA controller, I'll be able to install from the CD, but once I boot the system from the disks on the SCSI controller, I've never been able to get the CD device to show up in the operating system at all. It actually doesn't even show up in the bootloader when the bootloader is booting from the SCSI controller. So the way I solve this is just put everything on the SATA controller. And that way, essentially, it seems like there's this limitation where the system can only see one storage controller at a time. So if everything is on the same storage controller, I will be able to boot from my hard drives, but then still see the CD device and mount a CD image under VMS if I want to. So to do that, we will change this hard disk that VMware gave us, change the controller location to SATA controller 0. And I'm actually going to put it at SATA 00. And then down here on the CD drive, make sure that that's on SATA controller 0. And I'm going to put it at SATA 01. So that looks good. And I should just be able to remove the SCSI controller now. We don't need that controller at all. Okay, I'll put it on my correct VLAN. I have an internal network here. And the CD drive, I'm going to choose that ISO file. So that's the installation CD that I downloaded from the VSI service platform. And we have to make a couple of other changes. There's only one specific network adapter type that VMS has a driver for, and that is the Intel E1000. You can't use the E1000E that VMware selected by default here. You have to change it to the E1000. So let's just look at this again. 2 CPUs, 16 gigs of RAM, 72 gigabyte hard drive. I don't think USB really matters. Select your VLAN if you have multiple VLANs in your VM environment. Change the network adapter to E1000. And set up your CD to your image. And then again, make sure that your CD drive is on the SATA controller, which it will be by default, but also make sure that hard drive is on the SATA controller and that you've removed the SCSI controller. And we're not done yet. The VMware or VMS for x86 basically has no support for the console on the actual graphical console of a computer, of the VM. You'll see that the bootloader comes up on the machine's console, but for installation and then for the actual management console of VMS, it's only accessible over a serial port. So again, it's like you had your real physical machine where you did everything over the serial port to access it. Typically, VMS servers might not even have video cards in them or any kind of graphics adapter. You just did everything over a serial port. So we need to add a serial port to our VM. So I'll add other device and I'll choose serial port. And then for this new serial port, we want to use a named pipe. Now it'd be far more convenient to be able to use network and just telnet to a port on the VMware hypervisor server that would then simulate that serial port. But from what I can tell, the free license of VMware ESXi does not support the network serial port emulation. So we will use a named pipe instead. And the named pipe is basically just a local pipe file on the VMware server that acts as the end of the serial port. So we can only get to it from other VMs on the same VM server. So I'm going to call this pipe, I'll just call it VMS serial. And the near end, so this VM is going to be the server. I want to be able to plug something else into this virtual machine's serial port. And the far end is going to be another virtual machine on this ESXi host. Okay, so does that make sense? We're creating a serial port on our VMS virtual machine, and this serial port is going to be accessible from another virtual machine, and this pipe is basically the virtual serial cable that I'm going to be plugging in between the what we'll call the client machine and this server machine. So I need to remember this pipe name VMS serial. I'm just going to copy that to my clipboard right now. And the last things we need to do are over in VM options. Under boot options, VMS for x86 does not support traditional BIOS booting. It only supports UEFI booting. So just change the boot options firmware from BIOS to EFI. Does not support secure boot, so don't enable UEFI secure boot. And we don't really need to do anything in BIOS setup, so we don't need to do anything else here. We'll just choose EFI. So let's hit next and review all of that. I've created a virtual machine called VMS86, other 64-bit operating system, 2 CPUs, 16 gigabytes of RAM is more than the 8 gigabytes listed as the minimum in the manual. I have changed the network adapter to be an E1000. I have the hard disk on the SATA controller at port 00, and I have the CD drive on the SATA controller at port 01. We've created that serial port as a named pipe serial port in VMware. And I believe those are pretty much the important options. And then, of course, in the VM options, we set it to UEFI BIOS instead of the legacy BIOS. So I said finish to create that virtual machine. And that pops up down at the bottom here of my list, VMS86. Now, we need a serial console to be able to do the installation. So I'm just going to pick another Linux VM I have on this virtual machine server, this ESXi server. I have an apt proxy I run internally just to speed up updates to all of my Debian VMs. So it doesn't matter. I just need a Linux VM on this ESXi server. You could use a Windows VM as well and use something like Hyperterminal or PuTTY on Windows hooked up to the serial port. But I don't know, if you use Windows, I can't help you. Just get it out of your life. Use Linux instead. So to add a serial port to this machine, that's not something that VMware can add dynamically. So I'm just going to connect into this machine and shut it down. So I'll just go over to terminal here, and it should let me into this machine. Oops, that's the wrong username. Okay, so that machine's shut down. And sure enough, yeah, it shut down instantly. That's what we wanted. So now that this machine is shut down, we can edit it. And we can add a serial port. Now for this serial port, again, we're going to use a named pipe. And then I'm going to give it the same pipe name that I set up on my VMS VM. And this is what's going to plug this machine as a client into the far end virtual machine, which was our server. So again, on an existing VM, just add a serial port, named pipe, give it the same pipe name, and make it a client with the far end as another virtual machine. So I'll save that. I'll power on this Linux VM again. And we can see it start up here. Okay, it's back up and running. So if I SSH back to that machine, if I do dev ttys star, you can see that there are now serial ports in this machine, and ttys0 is going to be the serial port that we just added in VMware. So I'm just going to use the screen program as a terminal, as a serial terminal emulator. You just give it the path of the serial device you want to use. I'm running it as root because I don't think my user is in the dial out group that by default on Linux has permissions to the physical serial ports. And then you give it the baud rate that you want to connect at. And the VMS serial console is going to be running at 115,200, 115.2K. And give it my sudo password. Okay, so this is now my serial console plugged in to that VMS server. So now the moment of truth, after all of that setup, and again, all of those little details are important. If you don't basically do exactly what I've done here, you will eventually run into trouble. Let's power this on. Okay, so this is a little bit small on the screen, but this is the new VMS x86 UEFI bootloader. I'm going to switch over to that terminal really quickly. Yes, and you can see that I have a successful serial connection into my machine because this Linux box where I'm running a serial client is seeing that same text from the bootloader. Now, at this point, you can type and you can use the keyboard in the bootloader. And in fact, if you hit the tab key, you can choose the options at the top. So if I tab over to devices and hit enter, you can see that right now we see one bootable device, DKA 100, which is my DVD. And then DKA 0 is going to be my hard drive, which we'll see once we boot the operating system. So due to a quirk in VMware, and I think there might be a setting you can actually change in the config file on the host related to this, but it's not too important right now. I can't type over the serial console yet. The serial console won't come alive for typing until we actually start booting VMS. So I'm going to use this bootloader console to say boot DKA 100. And if we hit enter here, you can see it is booting an OpenVMS installation kit. If I switch over to the serial console here, we see the same thing. So it's actually loading, I believe, the whole installation image into RAM, and it's just going to boot from a RAM disk, essentially. Okay, here we go. And there it is, VMS Software Inc. OpenVMS x86 64 operating system. So this is it. This is OpenVMS running on x86 64 hardware. You can see it booting as VMware guest. It recognizes the hypervisor we're using. If we go back to the console now, you'll see it just says graphical output has been suspended. Use a terminal utility for access. So at this point, again, if this were a real machine, if you had a monitor and keyboard plugged into your VMS server here, it's totally useless. You can't do anything from it. You have to do everything over the serial console. Now, at this point, it's very familiar. This is just the same OpenVMS as on Alpha and Itanium. So the VMS for VAX installation procedure is very different. But if you have used VMS for Alpha or Itanium, you will now recognize this screen. You'll recognize the installation CD and you'll recognize the whole installation process. So I'm going to upgrade, install, or reconfigure, which is option 1. It's asking me if I want to initialize or preserve my disk. I want to initialize a new disk. And it asks, what is the target disk? And I can hit the question mark. And here's where you can see my DKA0 disk, which is the hard drive I want to install to. So I'll type DKA0. It asks for a volume label. I'll stick with the default of x86 sys. Do I want to enable hard links? Sure, we'll take that as a feature of the ODS5 file system. And it's giving one last chance before it wipes out this disk. We will say yes. Okay, so it's initialized it. We set the system account password. And the SCS node name, I'm just going to match the VM name I created and call this VMS86. Let's say we are planning to use DECnet. So it's asking what I want my DECnet phase 4 compatible address to be. I think I can use 1.5. I don't think I've used that on my network yet. Time zone specification. I'm in the US. I'm in the Pacific time zone. Yes, that's correct. And we are currently on daylight savings time. So you just say yes there. And it just computed correctly the time differential factor of -7 hours from UTC. So I'll accept that default. And yes, that's correct. Product authorization keys. So this is your license key for the system. Do you want to register one now? Sure, may as well. I will register a product authorization key. Yes, I have it. The one that you want to register here is the VMS base operating environment. You'll see that you have one called BOE, or high availability operating environment. You'll see one called HAOE in that license pack file you downloaded. Base are just the base features. HAOE, the high availability operating environment license, I believe gets you extra things like clustering and maybe volume shadowing without having to have the separate packs for VMS cluster or volume shadow. Not entirely certain, but they're all included in that license pack file that they're making available under the community license. So you just enter in the information from that. I will pause the video right now as I jump forward to after I have entered that license information. Okay, I've entered the license key that is in the pack file. So now you just exit this procedure. And you don't have to do that during installation. Of course, you can do it after installation, but this way you just avoid any license warnings during the initial startup. It doesn't really matter. I always like to just do the base OS license right here during installation. Now it's asking, basically, these are the components that are going to be installed: TCP/IP, SSL, OpenSSH, Perl, and then optionally we can install Deck Windows Motif. I don't think it has a full graphical environment like you'd be able to XDM into, but it does have the libraries so that if you have graphical applications, you can use them with a Remote X server. So I'll just say yes to that. I'm going to say no to DECnet Plus. I barely understand the old DECnet Phase 4, let alone the changes in DECnet Plus, so I always install the older DECnet Phase 4, so I'll say yes to that. And then do you always want detailed descriptions? Nope, we just want the defaults. We want it to install everything else that it wants to install. Okay, it's checking the signatures on all the packages to make sure they haven't become corrupted or you got a bad CD image downloaded. So that will validate the integrity of everything, and then it should start installing. And one last question, do you want the defaults for all options? Yes. The TCP/IP product is saying it will require system reboot. Well, yes, this is an initial installation, so that's actually going to be suppressed, but sure, we're happy rebooting the system. And do I want to review any of the options for these remaining packages? Nope. And here we go. It will install everything. Again, this looks just like installing on Alpha or Itanium. And actually, it mostly looks like the process after the first backup save set restore to install, even all the way back on VMS for VAX. The good news is this goes pretty quickly, right? This is a relatively modern, fast VMware server with fast disks in it. So we don't have to wait too long for all these components to be installed. I will, of course, speed this up. So I'll see you on the other side. Okay, almost done. Startup.nsh. That sounds like a UEFI boot file. So probably setting up the bootloader there so that we're able to boot from the hard drive. All right, it finished. It is now ending the installation process. It's actually setting up, and this is a new thing for how the VMS on x86 boot process works. It actually creates basically a in-memory RAM disk to initially load to boot from that contains, I think, things like the operating system nucleus or kernel and the drivers to access devices. So I don't know if it's fair to compare it to the Linux initial RAM disk sort of approach, but this little memory disk ends up showing up as a device with a file system, and that's actually what's being booted from. So whenever you apply updates or change things related to the operating system itself, the system will actually regenerate that to make sure the latest appropriate files are over there. So it says the installation is now complete. As always, it's going to reboot, and it will automatically run an autogen and then reboot the system again. So I'll just hit enter here. We want to shut down the system. We're done with the installer. And you can see here, shutting down the system. And it should auto reboot, or actually, yeah, hit any key to reboot the system. So I'll hit enter there, and it's going to restart. So if I look back at the system's graphical console, you can see we're back at the boot manager, except now, if you can read this, you see boot manager device is DKA0. So we are now booted off of the hard drive, not the DKA100 CD drive. But the default boot command still says boot DKA100. It essentially just remembers whatever the last boot command you used was. So I'm going to say boot DKA0, and now this will become the default boot command. So it says booting here, and again, immediately the console is completely useless. You have to use the serial console. But you can see here that sure enough, it is booting. It's running an autogen. So this will take a little while, and the system will reboot again. Okay, extending that dump file is finished. So it is now rebooting with the newly autogened parameters. And there we go. This time it restarted the system automatically. We're back at the bootloader. So if we go back to the console here, you'll note the auto action here is halt, but our default boot command is now what we want, boot DKA0. So you can type auto boot, and that will change the auto action to boot after a 5-second countdown. So from now on, whenever the system starts up, you don't need to come to this graphical console and type boot. You can just power up the VM, and 5 seconds later, it will start booting up VMS. And then once we have TCP/IP installed, of course, we won't need this serial terminal at all. We'll just be able to telnet in or SSH in if you set up OpenSSH after the machine boots up. And then the serial console here would just be available if we needed to troubleshoot a boot processor, right? If for some reason TCP/IP didn't start up. So you can just say boot here to use the default boot command, and now it is booting. So since I set auto boot, we should never really need this graphical console again. And if we go to our terminal here, yeah, it's already started up. So it does boot pretty quickly once everything's installed. Now I can log in as my system user, and welcome to OpenVMS E9.2-1 for x86. Do we have show CPU? Yep, show CPU. It's a VMware 7.1. We have 2 CPUs active, 2 CPUs configured, and we're up and running. So at this point, you would just do whatever you normally do on a freshly installed VMS system. Very quickly, I always like to create the network proxy authentication database. That just avoids an error during startup saying that the proxy authorization database can't be found. So we can MC authorize and then create the proxy database. There we go. Go back to our login directory. We can also initialize the queue manager and create our sysbatch queue. So new version will initialize a fresh queue manager, and then we can initialize a queue and start it. It's going to be a batch queue called sys$batch. So that's basic new VMS system setup stuff. Let's do DECnet configuration. So that would be, I think it's sysmanager net config. Remember, we're using DECnet phase 4, not DECnet plus. Default VMS 86, it knows the node name we already gave it. I'll take that. For some reason, it doesn't default to the address that we put in during the installer. So I'll just repeat 1.5. And then I just accept the defaults for the rest of that. It's going to show us the script that it's going to run to set up DECnet. And we'll say, yes, we want this commands. And of course, this is the serial console, so all of the opcom messages and everything are showing up on this console. It says that my DECnet keys are registered. That's included in the operating environment now. So do I want DECnet started? Yes. And that looks good. So if I show net, you can see that we have DECnet up and running at that address. And we can probably configure TCP/IP now. So that's at sysmanager : and I think it's TCP/IP $config. Yep. Okay, and then this will just be that menu system that you're used to from all of the other platforms for VMS. We'll just do the core environment. And it's quickest just to do options 1 through 5 using the letter A. And that'll walk through asking us the questions it needs to know. So internet domain, this is on my home lab VM system. So I'm going to say home.mattwilson.org. My Ethernet interface here is the gigabit interface. So number 1. I'm going to add a primary IP address. No, this isn't being used by clusters over IP. And I believe 103 should be available in my network. Host name is just going to be the machine's node name, so VMS 86. And that looks correct to me. So I'll exit that menu. Now I'll continue on to the next option, which is route D or gate D. No, we don't want dynamic routing. Yes, I want to configure a default route. And my default gateway is 192.168.42.1. We don't need to give it a name. We'll just hit enter. Bind server name, you can just put the IP address. So my DNS servers are at 192.168.42.5. Don't need to give it a name. And I have a second DNS server at 42.2. Again, don't need to give it a name. And I'm done, so you just hit enter. It confirms the time zone information. And we're done with the core options. So you can E to exit that menu and then enable a couple client components. I just enable FTP. So we say 1, may as well do the server. So yes, and then enable the server on this node. And the telnet client we will enable. So 7, enable telnet, which also enables the server. You can't enable and disable the telnet client and server separately like you can with some of these other things. But that should be good. That will let us FTP the additional products up to the server, and then we'll be able to telnet into it so we don't need to use the serial console to access it. If you check server components, just confirm FTP is enabled, telnet's enabled, and I don't believe we need any other server components enabled for now. Nope, we'll just keep this box relatively locked down. Okay, so let's start up VSI TCP/IP services for OpenVMS. And there we go. Hit enter and exit the configuration procedure. Now if I show net, you can see that we have our IP address set up as well. So if I open a new terminal, I should be able to get to this machine over the network now. So if I telnet to 192.168.42.103, sure enough, the telnet server works and we're on the network. So I can log in. Excellent. Set our terminal up. And it looks good. So that's it. We're up and running. Let's edit the system startup file so that DECnet and TCP/IP starts automatically. And then after that, we should just be able to boot this machine up unattended and telnet into it after it starts up. So edit sys startup. And the file is called systartup_vms.com. Again, this is all just like VMS always has been. Well, that's kind of messed up. Let me Control Z out of that, and I'm actually going to use I'm going to use xterm, which is the terminal whoops, no, not that one. Xterm, and then I have a profile set up here that fits on the video recording. Let's try that again. I'm going to say 42.103. Set the terminal type, and now edit sys startup vms.com. Yes, that looks much better. There's all these random terminal programs for Linux, but good old xterm still has the best, truest VT100 emulation. And if there's one thing VMS likes, it's accurate DEC terminal emulation with the VT100. So let's go down to, we created our batch queue. So I'm going to uncomment the start queue sys batch line. And I'm not going to do a background start. We're just going to say start network DECnet. So that should start up DECnet on startup. And if we scroll down, here's the TCP/IP startup command. So I'll uncomment sys startup TCP/IP startup.com. Hit Control Z to save and quit. And let's log off here. I'm going to leave this terminal here. Let's just clear the screen there. And back here on the system console, let's shut the system down entirely. So at sys manager, it's probably in system 2. We'll do shutdown. No, at sys system shutdown. And we'll just choose all the defaults to shut down immediately. And if you actually want the machine to power off, you use the option power off. So that should shut this down. Yep, there it goes. And if we go over to VMware here, in just another minute, it should be shut down. We can actually keep watching this. Yeah, powering down the system. Okay. Okay, so it's powered off. So at this point, I can do Control A and then backslash to quit screen. Disconnect entirely from that system I was using as the serial console. So now I'm just back to my local system here. And if we power this on, let me just pop open the screen to power it on. We should just be able to sit back and watch it auto boot. And then it should be on the network waiting for us pretty quickly. Of course, yeah, helps if I power it on. There we go. Okay, so you can see here the bootloader comes up and it's counting down because we set auto action to boot. And it's booting. And it says use a terminal utility for access. Well, we don't have the terminal hooked up, but we know that if we wait about a minute, VMS should finish booting and our startup scripts should now start up TCP/IP networking. So let's just ping 192.168.42.103. Yeah, it's already up and running. So if we telnet 192.168.42.103, we can get into our VMS system. Very cool. So this is it. This is VMS on x86. At this point, you can FTP some of those additional products up to it. Just FTP the zip files up to it. And then very important point, the unzip binary is installed, but it's in sort of a hidden location. I think if you look at syscommon syshelp.unsupported, see what's in here. Yeah, so in sys$common, and then the directory path syshlp.unsupported is the zip and unzip utility. So if you go into the unzip directory here, here it is, unzip.exe. So what you want to do is set up a foreign command to this executable. So I'll just copy and paste the path and then copy and paste the file name here. So the syntax for that is say what you want the foreign command to be. So we're just going to call it unzip, and then colon equal equal, and then a $sign, and then the file path. So if I hit enter there, now I can just go back to my login directory. Now, if I run unzip-v for version, you can see that we are able to use the unzip utility. So if you were to download the, we'll probably be logged out here. Yeah, but if you were to download the C compiler, for example, you would just use FTP to copy the zip file that you downloaded from the service portal to your machine, and then probably make a directory. So create dir, maybe just call it C compiler dot for current directory. So relative to the current directory, C compiler, change into that directory, and then you would unzip wherever you uploaded that, VSI C, whatever the version number is, .zip file. And that would unzip the product package, and then you just product install. You can probably just do product install star to look at all the packages in the current directory, and it would say, I found VSI C. You choose VSI C, and it would install the C compiler for you. So similar to the other packages, you are just able to FTP it up, unzip it, and install it. So with that, I will log off of the system, and that's it. Really the only tricky part, if you want to call it tricky, is just getting all of those settings correct for VMS. Make sure the hard drives and the CD-ROM drive are on the same SATA adapter. If you ever want to be able to see the CD-ROM drive again, make sure you've set the network adapter to an E1000. The serial port thing is probably the trickiest part, just getting a serial console that you can use from another VM on the same VM host. Again, if you have a paid VMware license, you can do this over the network. Instead of a named pipe, you just say use network. And then you would say something like telnet : //:12345 is the port you want it to listen on. Then you have to make sure on your VMware network firewall you've opened that up, but they have a serial port over network firewall entry there that you can enable. But on the free edition of VMware, you need to use a named pipe to another VM on the same host. All right, so if you plan on using VMware, that's it. That's how you get VMS for x86 up and running. If you are not using VMware, the other option is to use QEMU+KVM. So we're done with all of this. Let me just close my browser. And back here on my system, I think we downloaded, what was it? Yeah, we downloaded that zip file here. So let's make a directory called VMS VM. We'll just unzip that file here. And that'll give me the ISO file. Now, when I use QEMU+KVM, I don't use virt manager or anything like that. I just directly invoke QEMU myself. So those don't need to be executable. I don't really need the signature file because I don't have anything to verify it off of VMS. Okay, so there's the ISO image. So I'm just going to go ahead and create a hard drive image. So QEMU image create, call hd1.image, make it 72 gigabytes again. I just use raw images because I'm on a ZFS file system here with compression enabled. So I will, instead of using the QEMU CCOW2 format for snapshotting and cloning, I just use the native ZFS tools. So we have the hard drive image, we have the installation CD image, and the command we'll use to start this, I'm going to put in a file. So we'll just make a little shell script here. We run QEMU system, and it's an x86 64 system, of course. The machine type we want to use is Q35, and we want to use KVM acceleration. So that's what makes this actually use the Linux kernel hypervisor, not just a pure software simulation of a machine with QEMU. Match the CPU host. I'll give it 2 processors. I'll give it 16 gigs of RAM. And I need to give it a UEFI BIOS file. So let me pop open another terminal here. Just another X term. And it's going to be somewhere under your user share directory. And it's going to be named OVMF.fd, capital OVMF.lowercase fd. So we're just going to find under user share any file named OVMFFD. I'll take a minute as it scans that. Okay, so on my system, and of course we want the x64, that's the UEFI BIOS file that I need to use. If you're on a Debian type system, that's probably going to be under user share QEMU or user share OVMF. So just wherever it is on your system, you need the 64-bit OVMF.fd file. So I'll just copy and paste that into here. And then the all-important serial port. So we're going to create a sudo TTY that will be the simulated serial port to use as our serial console. And then the CD-ROM is going to be that file, which was called that. Let's copy and paste that. My hard drive is going to be a file, hd1.image. Put that at index 0 on the SATA controller. It is a disk, and we are using a raw format file. And I will put it on my network. So model E1000, just like we used in VMware. QEMU will emulate an E1000. And QEMU and VM network setup and bridging is beyond the scope of this video, but in my case, I have my QEMU environment set up such that user VMs are allowed to bridge to a network interface I have called BR0, and that will drop the VM directly on my real physical network. Okay, so let's review that really quickly. QEMU system x86-64, machine is a Q35 with KVM acceleration, emulating the host CPU using 2 processors, 16 gigs of RAM. The BIOS file we found, we are creating a serial port. And we want that CD on the CD-ROM drive. We want that hard drive image. That all looks good. And then an E1000 NIC. And then in my case, I should be allowed to bridge that NIC to my BR0 interface. Okay, make that executable. I have no idea if this user I'm logged in as to record the video is even allowed to use KVM. I guess we'll find out here. Yes. Okay, so now QEMU pops up the monitor for this machine, and you can see it's that VMS bootloader. Very importantly, the character device is redirected to dev PTS 55. So let me copy that. And that's what we will pass to screen. And I don't need to run sudo here because I'm running the QEMU as this stream user. So I will have permission to that device. In fact, we can list it here. You can see the stream user has read-write access to this pseudo terminal that's created. So if I do screen dev PTS 55, 115, 200, we now have the serial console for my QEMU-based VMS machine. Now, unlike VMware, I can start typing here. So I can say boot is a DKA 200 for my CD drive. And the VMS installation is starting up. Okay, so this is my monitor plugged into my virtual machine. And then this is my serial console plugged into the serial port of my virtual machine. From here on out, it's just like VMware. You'll see the same installer come up. The disk will be DKA 0 that you're installing onto. You can set auto boot so that it'll boot automatically when you start it up. As you can see, the graphical display is suspended. We can't do anything else from here, so we can just move that to the side, and we use the serial console. So in a lot of ways, much easier than with VMware because I'm just able to create that local pseudo TTY as my serial interface, and we just continue with the installation here on DKA 0. Accept all the defaults, say yes to that, say yes to that, give it our password. Node name, we'll just call it QEMU VM 1.6. And we go on with the exact same installation procedure. I won't install the pack this time. Say yes, say no, say yes, say no. And it does the product kit verification and it'll do the installation. The only thing I've noticed with QEMU is when the system shuts down or restarts, it appears to just hang instead of actually restarting the machine. So when it gets to the point where it was supposed to restart, you just go here and you just say machine reset, and then that will reset the machine. A little bit annoying. I don't know if there's a way to fix that with, there's so many little tweaks and options, and you can provide SMBIOS information and all sorts of things in that QEMU startup command. But that's the only observation I've had so far is you need to actually, reset the machine, or when it's time to shut down, you actually just need to quit QEMU. It doesn't happen automatically. It just hangs. So we'll see if that's ever fixed or if it's something that I'm doing wrong. But otherwise, it works great under QEMU from what I've been able to tell. So that's pretty exciting. So at that point, you are ready to install VMS. You can install some compilers and then, I guess, start porting your VMS software you've written for VAX or Alpha or Itanium over to x86 and dominate the world as a VMS hobbyist. As always, if you have any questions, feel free to leave them down in the comments below. Let me know what you plan on using VMS on x86 for. I know a lot of the sort of fun old software for VMS on VAX and even Alpha never got carried forward to Itanium and certainly not carried forward to x86. So unless you have homegrown software that you plan on running on VMS, I'm not sure what you would do with VMS on x86 64. So I'm curious what kind of software you have source code for VMS that you are looking forward to recompiling and running under VMS for x86. The great open source web server for VMS works, so that WASD, W-A-S-D. So you could run your little web server on VMS. But yeah, otherwise, let me know what you're thinking. Thanks so much for watching the video, and I will see you next time.